So this is to introduce you to worksheets 2 and 3 in your workbook. So these are the worksheets in Unit 3 that are introducing accelerated motion. Remember though, we are always going to have uniform acceleration, and worksheet 2 is on page 102 and worksheet 3 follows that. So I'm just going to do one example from each worksheet to get you started. So the first example here is a ball rolling down a ramp. In all of these situations, we are ignoring friction because we have not discussed that yet. So we're going to say this is a frictionless ramp in all situations, so we don't have to deal with that force. So you need to pay attention to like where they're starting, where you're at, and where your ending point is. So when this ball rolls down the ramp, we should obviously know that it's starting from rest, and as it goes down, it's going to increase the spacings between the ball. So they want you to do a motion map. So if I did a motion map, it's at rest, and then it's moving faster, faster, and faster, and so on. Okay, so that would keep going. So we want to sketch the graphs for this. So we're saying that where the ball starts is at 0 position and it's moving to the 50 centimeter mark. Now my worksheet set up a little different from yours because you have, I think, just one set of graphs on the next page. Mine was condensed, so I have really 2 sets of graphs on this page for problem 1 and 2. So we need to pay attention to, it looks like it starts here, and we know it's accelerating, so we should have a curved line, and it makes it to the 50 centimeter mark. Okay, I just did my motion map, and my motion map is showing in the blue the velocity vectors. It looks like it's increasing, so if I was to show that and it's starting from rest, it would be increasing. Okay, so it's speeding up. Because if I looked at my tangent lines here, I could say, oh, that one's flat, it's 0. Oh, draw that tangent line through 1 point. Aren't these getting steeper as time goes on? Right, so the velocity is increasing. Now, the other part is the acceleration. So the slope of this graph, the slope of the velocity versus time graph represents this acceleration. Therefore, this slope is constant, it's positive, it's a positive constant slope. So that means my acceleration is also going to be positive. It's in the positive region and it's constant, so it would look like this. So this would be my constant or my uniform acceleration. So you are supposed to produce all of these graphs and the motion maps. Now, I also would like you to add the acceleration vectors on here when you do the motion map, and I'm going to do those in red. And those acceleration vectors, in this case, it is positive, and this is the positive direction, and it's constant. That means I'm going to put a vector, I'm going to put them in red, up here on every dot that I have for the velocity vectors. And notice, I'm drawing them the same length, representing that it is constant. Okay? So I'm just matching up what dots I have for this are matching up to the acceleration to say, yes, it is constant and it is to the right. So it is positive also because it is going in the same direction as the velocity vectors. So these are my acceleration vectors. These are my velocity vectors in the blue. Okay, so that should get you started with this. So you should be able to look at those diagrams and figure out what's happening and then sketch the graphs for each situation. Worksheet 3 is a continuation of worksheet 2, except now they are just giving you a position versus time graph, and they're asking you to sketch the other graphs, do a motion map, do the velocity and acceleration vectors, and then do a written description. So I'm going to look at an example on this one. Make sure you notice that, like, if they divide the position time graph into segments, you have 2 different motions that you need to account for, and then they should match up to the other examples. So let's look at number 6, okay? On number 6, it looks like I have 2 segments, and it looks like in the first segment right here, this looks like this is a constant slope, and that slope is positive. Oh, so that means my velocity is constant and it's positive. I'm going to sketch that there. So remember, to get the velocity, we use the slope. Now, if I look at this slope, isn't it starting out steep and it's getting flatter? It's still a positive slope, right? But it's slowing down. So I'm going to still be in the positive region here on the velocity versus time graph, but I'm going to slow down because this is 0 velocity right there. If I looked at this, it looks like that is flat, so it would be standing still at the last moment. Now I want to go down to the acceleration graph. Now these slopes represent the velocity, or represents the acceleration from the velocity versus time graph. Right here, this slope value is 0. So I'm going to have no acceleration because my velocity is constant. I'm not changing my velocity if I'm constantly going the same one. This slope right here is negative and it's constant. So I should be somewhere in this region to match up for that time frame. Now, I need to go down and do my velocity vectors and my acceleration vectors. Now, if I go back up here and look, it looks like I started at the 0 position, so I'm going to start at the 0 position. And it looks like, I'm going to try to do this in the least number of vectors. It looks like I was going constant first, and then I was slowing down. And I'm going to say I stopped. That's my velocity vectors. Now my acceleration vectors. For the first part, if you look, there is no acceleration. So I am just going to put dots and not a vector on those to say, yep, there's no acceleration. But this part right here, there's a negative acceleration. Negative is always to the left, so the acceleration, but it's constant, should be pointing that direction to the left. And even this dot right here gets an acceleration vector on it because the object is slowing down to a rest, so there is an acceleration acting during that period of time, that last second interval. So, and then you could do a description. You could say starting at the position of 0, 0, or the origin, the object moved away with a constant positive velocity, and you don't have any numerical values on there, so you would just be doing a qualitative description. So this should get you started with this worksheet also. Good luck. Let me know if you have any questions.